looking at our measurement packet, and we're on the page called Graduated Cylinders, and we're talking about how to measure the volume of a liquid using a graduated cylinder. Okay, so the most important step is to look and see what is our scale along the side. Remember when we talked about graphing and we had a scale and an interval? Do you remember what that meant? What is the scale? Caden?
The scale is like the thing that we use when we measure something.
They're the numbers along the side. Okay, and the interval is how much is in between each line. Okay, so we said that the interval had to increase by the same amount each time. So we could go up the scale by 2s or 5s or 1s, but whatever we started with, we had to go the whole time. Move up to the middle, please. Okay, so on this one, if this is 0 down at the bottom, our scales always start with 0. Please be looking at the screen. I have a couple people not. The scale always starts with 0, and this is 10. What are each one of these little lines? How much is that? Are they 1? Is it 0, 1, 2, 3, 4, 5? What is it? 2s. Everyone point to them and count with me. 0, 2, 4, 6, 8, 10. Now, look at number 2. Here's a 0 and here's a 5. What is this scale?
1.
Count them with me. 0, 1, 2, 3, 4, 5. It could look like this. Here's a 0, here's a 10. Look at the scale. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And then back here we're counting by 2s again. The most important thing that you have to remember is to look at the scale and decide what do each one of those hatch marks represent. Okay? 40. I wanted to show you something. I'll have to show you on another graduated cylinder here in a minute. Oh, I've got one. Okay, we have this graduated cylinder. No. Hold on. I saw one and I want to make sure that we pay attention. Hold on. There's one around here somewhere. Oh, here it is. These glass ones. These glass graduated cylinders, I have a question for you. Okay, please listen. Okay, this is important. Careful, you're on camera. Guys, please, no thank you. Okay, let's look at this graduated cylinder. Look at the scale. Tell me something that you notice. Tell me something you notice on the scale. What do you see? Shh, raise your hand. Let's be thoughtful. What do we see? Ryan? What is something that you notice? Well, first of all, what's the interval? What do each of these lines represent? Can you tell me that? Here's 60, here's 70. How many lines are in between? Is it 62, 64, 68, 70? Hey guys, look at it and answer the question. This is easy. Please quit looking at the camera. 10. Thank you. 1. They're moving up by 1s. Thank you, Ryan, for participating. So look at 60, 61, 62, 63, 4, 65, 66, 67, 68, 69, 70. But look over here. What do you notice here? Caden R., what do you notice?
The other side, the other numbers are red, and the other ones on the right.
Okay, there's numbers on the left and numbers on the right. What do you notice about them? Caden?
We got on the left. The 0, 10, 20, 30.
Right, these are increasing. They're going up as you go down. These are going up as we go up. which number would tell us? When we look at this amount of water, how do we know which side to use? How do we know which side to use? Is it 44? If I count from here, it's 10, 20, 30, 31, 32. I'm sorry, 42. Or is it over here? Is it 58? How do I know which one to use? Stella?
Because the 40 is right there and the 50 is right there. So it's under the 40.
But which scale am I going to use? Am I using the scale that is
The other side.
going up, or am I using the scale that's going down?
Going down.
Yeah, this is 0 down here, so that would have been 0, and that's 0, right? It's not 100. If we had nothing in there, it wouldn't be 100, would it? It would be 0.
Yeah.
Okay? And if we came up to here, it wouldn't be 90, it would be 10. And if we come up to here, it wouldn't be 80, it would be 20. These numbers on the left are how much did you pour out. If I went and poured some out, you would see, oh, she poured out 8 milliliters. Or, oh, I could still add 42 milliliters of water here. That's how much room is left. Over here, it's telling you how much water is in there. So you have to pay attention. This is only on the glass graduated cylinders. But on the glass graduated cylinders, you need to use the scale that's going up. Think of it like this. If it were empty, it would be 0, not 100, right? Does that make sense?
Yes.
Okay, so what I'm just trying to show you there is that you have to pay attention to the scale, okay? Now, let's practice reading it. We want to make sure we can do this. Okay, so the first one, who can tell me how much liquid is in number 1? Every hand should be up. Some of you aren't even looking at the right page. How much liquid, Carter? 24 what? Okay, you're pretty close. 24 milliliters. Levi? 25 milliliters. Here's the cool thing about measurement. I'll usually give you about 1 off either way. See, I think it's a little bit between the 24 and the 26, so I would probably put 25. Remember, you need to put milliliters. I really like the way Carter added milliliters to her answer there. Okay? You capitalize the L in your label. Okay, but if I put 25, that means I would accept 24, 25, or 26. I don't expect you to see it perfectly every time. Now, one thing about the graduated cylinders, which is true also for the balances, is you won't see it accurately unless you get down at eye level. Because of that meniscus, you won't see it accurately if you don't get at eye level. The same is also true. We don't want to shake the table. Okay? Okay, number 2. Let's look at it. What do you think it is? How many milliliters? For number 2. Luke.
8 milliliters.
I don't think it's 8. Look again. Look, here's 5. Count up. 6, 7, 8, 9. 9 milliliters. Okay, what do you need? Okay, I need you to do your work with me, please. I need you to do your work with me, please. Number 3. What is the volume of this liquid? What's it measuring to on number 3? Alex. I think 2. 40 what?
40 milliliters.
40 milliliters. Okay, now I want to skip down to these. Come to the bottom. It says 4 different objects were placed in a graduated cylinder one at a time. So when it says which object has the greatest volume, which has the least volume. When this graduated cylinder just had water in it, how many milliliters was it holding? How many milliliters is that? Be careful. Look at the scale. How many milliliters? Harper? 17, 15, 16. This is 17 milliliters. So look at 8. When they added the battery, what did it rise to? This is just like you jumping in a hot tub. How much did that water rise when they added the battery? Yes, Stella.
22.
To 22. These are each by 1. So let's answer the question. What is the volume of that battery? What's the volume of that battery? Carter Nelson. Now that's the battery plus the water. The water was 17. The battery added into the water is 22. So what is the battery by itself? I think she's getting it. Let's give her a second to get it, and I'll call on you for the next one. Maybe. Five. You have to do 22 minus the 17, and that would leave you with 5 milliliters. The battery has a volume of 5 milliliters. 22 minus 17 is 5. So the water by itself was 17. The battery plus the water is 22. That means the battery was 5. Okay, what about the nail? What did it rise to for the nail? What is the total measurement of the water plus the nail? Cordelia?
18. I mean, no.
Yes, 18 milliliters. Okay, but you need to be writing these down, please. Okay, so what is the volume of just the nail?
1 milliliter. 1.
1 milliliter. It's 18 minus 17. It's 1 milliliter. Okay, what about the button? What did the water rise to for the button? Levi? 19 milliliters. Okay, what is the volume of just the button? Who knows the volume of just the button? Morgan? 2. It's 19 minus the 17, which leaves us with 2 milliliters. Okay, what about this key? What did it rise to when they put the key in there? Avery?
It rise to
20
20 milliliters.
milliliters. Okay, what is the volume of just the key? Caden? 3. It's 20 minus 17, and it leaves you with 3 milliliters. So what object had the greatest volume?
The battery.
The battery. You probably could have guessed that, right? What object had the least volume?
The nail.
The nail. Okay? Okay. I honestly think that we should probably just finish this page instead of moving to measure, and we'll do the measuring the volume in the graduated cylinders tomorrow, because we have to be in specials in 5 minutes. Okay, what? Okay, no, we can't just avoid specials.